Right, so in this previous video we talked about the measures of central tendencies, and then we talked about how the variability is actually defining your data. And now we want to understand the third pillar of understanding the data, which is called shape of the data. Now I must be wondering, like, why we want to understand the shape of this data. And trust me, in a minute you will have a clear understanding of what is the shape of the data I'm talking about. So just let me just give you some idea about like this shape of this data. The shape of data is measured by skewness of the data and kurtosis of the data. Now if you just look for the skewness of the data, this is how the skewness and kurtosis will look like, right? So if you just look for this value over here, so measureness, it actually measures the asymmetry of the data, right? Whether my data is symmetric or not. And if you look for the right hand side figure, it's actually a positive skewed data where the right tail is much more longer, and then you have on the left hand side which we have negatively or left skewed data, which is having the left tail which is much more longer. So if you see that, this is how my data will look like. Now you must be saying, like, how you actually wanted to describe this data. Now let me just give you some idea about how this data works, and I'm going to like delete my old drawings over here. But yeah, in a minute, like, probably I can just explain to you with the previous drawing as well, right? So let me just do this. Okay, say I have a value over here, right? And this value has got some elements, like the frequency of this elements is much more higher. So if you just look for this elements, so if I say I have very few values here, and by the time I'm reaching here, I start getting very high values, right? And then I have few values over here. Now what will happen if you just look for the frequency? Now if I just say how many times a particular value appeared, right? Just look at this. If I say how many times a particular value appeared, right? So I would say this is 4.3, then this is 4.7, this one is 5.3, and then this one is 6.5, and so on and so forth, and this one is 7.5, and this one is 9.8, and this one is 11, and I keep on doing that. Or I can do one thing, right? I can just create the graph of the frequencies. For example, so if I have this graph, I would say this is 1, this is 2, this is 3, and so on and so forth. And I would say how many times I got 4.3, so it says 1, and then 4.7 is again 1, and then 5.3, and then here I have multiple lines together, very much huge lines together, and then I have all the values are 1 because there's no value which is repeated or something, right? Something over here. So you got lot many values. Or what I can just simply do is, let me just remove this. I can just simply say cumulative frequency. Now what this cumulative frequency means, I would just create a graph over here like this, right? And I would say over here, you know what, I would like to find out all the elements which are lying from 4 to 5, then 5 to 5.5, or like 4.5 to 4 to 4.5, 4.5 to 5, 5 to 5.5, 5.5 to 6, 6 to 6.5, 6.5 to 7, 7 to 7.5, right? And 7.5 to 8, and so on and so forth. And what will happen, this will say you have only one element, which is 4.5 to 4 to 4.5, then you have one element. Do you have 3 elements here? You have like 6 element or 7 elements over here, then you have 10 elements over here, then you have again say 8 elements over here, and then you have 3 elements over here and 2 elements over here, right? So what am I gonna do is I'm going to plot them against it, right? Against like this. I would say this is 1, this is 2, or I would say this is 0, this is 2, this is 4, this is 6, this is 8, and this is 10 over here. This is my 10 value, and I would say 4 to 4.5, right? I would say cumulative graph is 3. Then 4.5 to 5, I have got only one graph, like one value, which is like this. And then I have 4.5 to 5, right? There will be a value of 3, right? And then we have value as 7, so I will just go till here, right? And then I would say value goes to 8, and then I go till here, right, like this, right? And then I would say the 8 value, right? So I'll just plot it till 8, and then 3, and then 2, and then probably 0 or 1, whatever the values are, like whatever the values I have. So this would be my graph, right? And if you remember, right, in your school time, you might have done this, right? You might have actually created a bar like this, right? So, and then your teacher might have asked you to connect the middle points like this, like with via a smooth line, something like this, a smooth line like this, right? So this, if you just remove the bars from this complete scenario, you will end up getting a graph like this, right, which will be like this, right? Now if the higher values, if the higher values are much more like if the higher values are much more higher in number, probably you will get a graph like this, right? A graph like this, right, like this, right? And if it's vice versa, then probably you'll get graph like this, right? So if I'll just delete the complete stuff and I'll just try and plot that graph for you once again, right? Look at this. So this is my graph, okay, which I'm trying to plot. And if you just look for this graph, let me just delete that for you, and I am choosing blue color, one of my favorite color, and highlight it a bit. And I would say I have very few values over here, and then most of the values are lying like this, right? I have highest frequency in this area, in this region over here, right? And if I say the lower value in the middle, like lower value in the middle, and then I have a higher value like over here, right? Now you must be wondering, like, why we are even discussing this graph, and why it's just that we need to identify where exactly my higher management is actually, or where exactly higher values are aligned over here, right? So I would like to give you one example, and that example is pretty simple. Let me just give you some imaginary numbers, and things will start making sense to you. Here I have number of people, right? So let me just, okay, let me just do that for you over here. Okay, let me just plot that graph for you. I'll create a good graph over here, a bigger graph, probably it will make much more sense. And I'm gonna delete this value from here, and I want you to think in this perspective, okay, that we have salaries over here, salaries, right? And we have number of people, right, in the company, right? If you look for some companies, probably you will find that the graph of this company will go like this. I would rather pick up a little bold thing, right? Just look at this, right? This is how the graph will look like, right? Or even it's not like this, it's like this, right? It's like this, it's like this, very much like this, and it ends over here, right? Now look at this, right? This is the highest salary, okay? This is high, this point is the highest salary which is being offered in an organization, and this is the zero salary, right, which is being offered. And here is the number of people, like, so five people are here, 10, 20, right? 30, 40, and then probably if you go till here, probably you have say 200 people in an organizations, right? So just look at this, right? Or maybe even like say, so there are, if there are 1000 people in the organization, right, what will happen? There are few people who are getting this much of salary. So this is 10, right? 10 people are internship, right? They are earning very few amount, like 0 to say $10,000 a year or something like that, right? $10,000 over. This is $20,000, 30, 40, 50, 60, and this is where we have like $250,000, okay? So just look at this, right? So there are some people who are interns, either they are earning no money and they are earning very few. There are few people from here to here, right? This portion, this majority of the portion is earning. There are 20 people who are earning from 10,000 to 20,000. They may be having some mundane kind of job. They might not be earning that much. And then the majority of the people are actually lying from here to here. If you see here, like this is $25,000, if you just look for this, to $75,000. Most of the people are lying between this. And if you just notice over here, the more I'm going towards the package, the lesser the number of people who are getting it. And finally, if you reach over here, there are only 1 or 2 people who are earning $250,000 salary or $300,000 salary, right? So this is the typical case of a company, of an organization, right, where you have a skewed graph. So if I know the range from 0 to 100, I know where the most of the people, 50% of the people are lying. Actually, these are the 50% of the people. So I'm just assuming this is 50%. I know what 50% of the people are actually getting as a salary. I know that the maximum and the minimum, and I can define my data. So if I even I want to define the you know, what do you call it, the box plot for this data, this is how I will define. I will just delete this, right, for a while, right? And this is how my box plot will look like. Now I want you to think this perspective this way. Just look at this. This would be my box plot, and this is how my box plot will work, right? Now this is how my box plot will look like. Okay, I hope you understand this. Okay, so my box plot is more towards minimum value of the data, and that's where box plot are very much helpful. I actually can tell you, right, where is your 50% lying of the data. So I hope you are able to connect that dot, right? Now the next thing which I wanted to talk about, like, I'll just delete this whole stuff and I'll create one more. And again, I'm just picking up the similar characteristic of the graph. When I say similar characteristic of the graph, I want on the y-axis I want the number of people, and I want on the x-axis I want the salary. So I will just simply say, here we have salary, how much salary you are getting, right, annual package, and this is number of people, right? So the previous example was of a company. Now I want you to help me identify what kind of, like you getting over here, what kind of inferences you're getting over here. So if you just look for this graph, probably this is how the graph will look. And if you just don't do that, right, if you just probably create a graph like this, consider this as a smooth image, right? This is how my graph looks like. Okay, now when I say this is how my graph looks like, it means that my graph is actually showing me this kind of behavior. What kind of inferences you can draw from there, basically, right? Just let's consider this is smooth, right, and this is going like this, okay? So just think. Now if you notice some major point over here, right? Here I have salary, which is low salary. I would not say zero salary, I would say low salary. And this is where we have higher salary. This is the number of people. So you have 5, like say 2, 4, 6, 8, 10, 12, 14, 16, and so on and so forth, like 20 values over here, right, as well. So you've got, like, very few people are getting low salaries, and there are most of the people like most of the people, like which is like 50% of these people, like from here to here, they are getting higher salaries, right? They are getting almost equal salary, I would say. They like, so the packages are like, there's somewhere this guy is getting say 65,000 and this guy is getting 75,000, 75,000 salary, right? So most of the people are getting almost equal salary, right? And there are very few people who are getting say 80,000 salary or 85,000 or 82,000 salary. Now this is a typical structure of a team where everybody has a similar roles. Like everybody is software engineer, everybody is working in .NET engineer, they have got the similar package, they have got similar years of experience. However, some people are at 65,000, some people like got 2 or 3 appraisals, they reached at 75. Some people are like very low, they are the new entries in the team and they are earning say $45,000 a salary and so on and so forth. But this is the typical structure of a team, and there will be very few people who are very senior member of the team and they are getting like 82,000 or 85,000 salary, and then their next promotion is due. Once they got their promotion, they will probably move to a next league altogether. But this is a typical structure of the team. So if you know the middle 50% of the data, if you know the middle like the range of the data, you can talk about this. Now in this case, if you draw the box plot, this is how you will draw it, right? So basically your 50% would be lying somewhere here to here, and this is how it will be much closer to your like much closer to the maximum value, right? This is how, and this, if you notice this is exactly opposite to what you have seen. This box was much closer to the minimum value earlier. Now it is much closer to the maximum value over here. So this graph represents the team behavior, right? A salary of a team, right? So I hope it is making sense to you guys, right? What I'm talking about right now, and how this whole thing works, right? How this the values of skewness make sense, negative skewed and what is positive skewed, and how your data is moving. Then the last thing which I wanted to talk about in this is called kurtosis, right? Which is nothing but the peakedness of the distribution of the data. Now this peakedness is where you have like the very high peak, right? Very pointed peak, then it is called as leptocortic. If it is like normal kind of peak, right, it is mesocortic. And then we have platycortic, which is almost flattened, but there is a small peak, right? But it is also it also looks like a peak. However, the values are much more flattened and not much distribution or heavy distribution is being expected out of this. But this is called kurtosis of the data, which also defines about the data. So if you know that measures of central tendency, if you know the range of the data, if you talk about the standard deviation of the data, if you know the interquartile range, if you know whether your data is actually having negative or positive skewness, or if you also know that the data has got some kind of kurtosis, then probably you can define your data set in a pretty much heavy manner, right? Or you can just define everything about the data, I would say. So I hope you're getting the sense of it, right? What your data science is all about, and why it actually requires statistics to deal with this kind of situation. And this, my dear friend, whatever we have understood is always about the one column of the data, where we have only one column, and how do I actually get into the one column of the data, right? So I hope it is making sense to you. In the upcoming videos, we talk about more in statistics. I want you to stay tuned with me and learn more things about the statistics. See you next, and happy learning.